Okay, I'm going to do out two problems that people are struggling with here from Monday's assignment. So for number 4, you see b plus 4 and b plus 5. So remember, these are binomials. You can't just be like, oh yeah, this one, come on and focus here. This one has a b and this one has a b, and oh, if I just added 1, this would become a plus 5. That's not how dealing with fractions work. So to be able to change a fraction, you can multiply that fraction's numerator and denominator by the same term. So we can't just add things on to denominators, right? Like if I just had 3 over b plus 4 and I said, oh yeah, I just want to add 1 to that. You can't just add 1 to a denominator. You're adding 1 over 1 to the whole fraction, which is 1, which means you're really adding for common denominators. To add fractions together, the denominators would have to match. So really, this is b plus 4 over b plus 4. So for people who are just trying to add numbers into the denominator, that's not how fraction arithmetic works. Okay, just like what we learned in elementary school about fractions. So the first thing in this case is to realize that, all right, these are two different denominators. It would be the same as if I asked you, well, what's 1/5 plus 1/7? You don't just say, oh, I'm going to add 2 to the 5 to make it a 7. That's not how fraction addition works, right? You say, oh, it has a common denominator of 35. So I'd have to multiply this one by 7 over 7 and this one by 5 over 5. 7 times 1 is 7 over 35 plus 1 times 5 is 5 over 35. The denominators are the same, so I write 35, and then I add 7 plus 5 to get 12. So that's like a little review just about how you deal with fractions in general. So let's look at the more complicated ones. What's our common denominator of b plus 4 and b plus 5? Just like with the 7 and the 5 down there, I have to multiply these two together, b plus 4, b plus 5. And I look and I say, all right, well, this first denominator has the b plus 4, but it's missing the b plus 5. So that means I have to multiply the top and bottom by the binomial b plus 5. And the second one you have to multiply by b plus 4, because that's what it's missing from your list. So your first numerator is now 3 times b plus 5 over b plus 5 times b plus 4 plus, again showing you every step here, too much red, 3b times b plus 4 over b plus 5 b plus 4, taking it one step at a time. Distribute in your 3, you're going to get 3b plus 15 plus 3b squared plus 12b, all over the same denominator of b plus 5, b plus 4. So now let's combine like terms in your numerator and write it in standard form. So I have 3b squared plus 3b and 12b is 15b, and then just a 15. So a lot of people have, I can tell they've been watching the videos and they try to factor the numerator to make sure that nothing cancels out. So you could factor out a 3, and this is what you'd be left with. Okay, nothing's changed in the denominator. And so to continue with factoring here, you're looking for two numbers that multiply to 5 and add to 5. That's not possible, so that means you can't factor that numerator. So this is done. You cannot simplify anything here. These 5s, guys, do not cancel. I've seen people doing that. Why? Because this 5 is part of this whole trinomial. This 5 here is part of that whole binomial. So to cancel b plus 5, you'd have to have the binomial b plus 5. All right, just not part of it. Another one to help people out that people have been struggling with, number 6. Mistakes people are making is they're like, oh, hey, I'm going to cross cancel those 3s. No, that only works when you're multiplying fractions together. When you're adding fractions, you can't cross cancel like that. But if this was a 3 right here, 3 over 3, yes, then you can cancel. If they're directly over each other, they can cancel. So what people have done here is they have factored the second denominator. So they've taken out a 2 just to see if we have anything, which we're not going to, but I'm going to just show you. So I'm looking for factors of 6 that add to negative 5. So hopefully you're going to tell me negative 2 and negative 3. So guys, this negative 3 has nothing to do with this 3. And this one's a little tricky because these two denominators have nothing in common. And I ran out of room. What else is new? So I'll write my common denominator down here. So between 3 and 2, it's just 6. And then an n minus 2 and an n minus 3. If that's confusing to you, just go back up here to the original problem, and you can say, okay, let me just multiply these two right off the bat. I need a 3 times the other denominator, 2n squared minus 10n plus 12. These two are the same, they're just written differently. So I might, what I've seen from people's papers, it seems like this way makes more sense, so I will explain it that way. So that first denominator, we have a 3, but we don't have the 2n squared minus 10n, come on and focus, plus 12. So that means I have to multiply that first fraction by that trinomial. Okay, and that second denominator right here, maybe it might make more sense to show you this. This is down here, this is just that first step in factored form. But at any rate, we have the 2n squared minus 10n plus 12. It needs a 3 right here. So that means I have to multiply the top and bottom. Whoops, let's do it down here by 3. Okay, so I have a 2n times, just writing out what we have because writing things on slant is not really great, plus 3 times 3 is 9, and now they both have the same denominator. Okay, so people have left it like this, but you need to combine like terms and distribute in. So 2n times 2n squared is 4n cubed. And then I'm going to have a minus 20n squared and a plus 24n and a plus 9. And that's all over the same denominator. So your numerator here, the 4, the 20, the 24, and 9, those don't have anything in common. You can't, thank you, you can't take anything out of all of them. So this is actually it. This is your answer. You could try to factor this if you took a 4 out of here, factor by grouping, but you're going to see that you won't get the same thing with the 24 and the 9. And that's my signal to stop this video.